Welcome to PreMath. In this video, we have got these two vertical segments, ED and FC are fully confined in a semicircle with the center of, as you can see in this diagram, such that this segment DE length is 2 units, whereas this segment CF is 1 unit. And moreover, this length EF is 3 units. And now our task is to calculate the area of this blue shaded region. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. We must find the radius before we could calculate the area of this blue shaded region. So therefore, I have connected this center O with these points C and D. And as a result, we got these radii, this radius OC and this other radius OD. Let me label this radius as lowercase r and this radius lowercase r as well. And now let me go ahead and label this segment EO as x units. And since this whole length EF is 3 units, so therefore this segment OF is going to be 3 minus x. And here's our next step. Let's focus on this right triangle OED. And now we are going to use the Pythagorean theorem for this triangle. And here's our Pythagorean theorem, a square plus b square equal to c square. So let's go ahead and fill in the blanks in Pythagorean formula. So we are going to have x square plus 2 square equal to r square. Let me go ahead and call this our equation number 1. And now let's focus on this other right triangle OFC, whose side lengths are 1, lowercase r, and 3 minus x. Let's apply the Pythagorean theorem on this triangle as well. Let's go ahead and fill in the blanks in this Pythagorean formula. So we got 3 minus x whole square plus 1 square equal to r square. And now let's recall this famous identity. A minus b whole square could be written as a square minus 2ab plus b square. And we are going to apply this identity on the left hand side on this binomial. So therefore we are going to have 9 minus 6x plus x square plus 1 square is 1 equal to r square. And in this next step, I have combined these like terms and put them in a descending order. So therefore we can write this thing as r square equal to x square minus 6x plus 10. Let me call this our equation number 2. And here we are ended up with these equations 1 and 2. And now we are going to compare these two equations since the left hand sides are identical. So therefore we can equate the right hand sides. So therefore I can write x square minus 6x plus 10 is going to be equal to x square plus 4. And here we can see x square and x square, they are gone. So therefore we are ended up with the negative 6x plus 10 equals to positive 4. Let's subtract 10 from both sides. This is gone. So therefore we are ended up with the negative 6x equal to negative 6. And now let's divide both sides by negative 6. So therefore our x value turns out to be positive 1 unit. So therefore we can see that this segment EO, which is represented by x, becomes 1. And this other segment OF is going to be 3 minus 1 is going to give us 2 units. And now in this next step, I am going to substitute x equal to 1 value in this equation 1. So therefore, wherever we see x, I'm going to replace it by 1. So therefore our equation 1 is going to become r square equal to x value is 1 whole square plus 4. So therefore we ended up with r square equals to 5. And now let's do the square root on both sides to undo this square. So therefore our radius r turns out to be positive 5 units. So thus our radius r turns out to be square root of 5, and likewise this radius is square root of 5 as well. And now let's focus once again on this right triangle OED. Let me call this angle theta over here. And now let's recall the SOHCAHTOA, and we are interested in tangent of theta equals to opposite divided by adjacent. And in our case, our opposite side is 2 and our adjacent side is 1. So therefore our tangent of angle theta is going to be equal to 2 divided by 1. So therefore our tangent theta is going to be equal to positive 2, or we can write angle theta equal to tangent inverse of 2. And if we use the scientific calculator, our angle theta is going to be approximately equal to 63.435 degrees. So therefore this angle theta turns out to be equal to 63.435 degrees. And here's our next step. Let's make an observation. We can see the area of this blue shaded region is going to be equal to the area of this sector AOD minus the area of this triangle OED. So therefore now our task is to calculate the area of the sector AOD and also the area of this triangle OED. And now we are going to calculate the area of this right triangle OED. And now let's recall the area of a triangle formula. Area equals to a half times base times height. And in our case, our base is 1 and the height of this triangle is 2. So therefore the area of this triangle OED is going to be a half times the base is 1 times height is 2. And if we simplify everything on the right hand side, this turns out to be 1. So therefore the area of this triangle OED turns out to be 1. And now in this next step, I am going to calculate the area of this sector AOD, as you can see over here. And now let's recall the sector area formula. Area equals to angle theta divided by 360 degrees times pi r square. So let's go ahead and fill in the blanks in this formula. Our angle theta is 63.435 degrees divided by 360 degrees times pi times our radius r is square root of 5 whole square. And if we simplify everything on the right hand side, the area of this sector AOD is going to be approximately equal to 2.77. So therefore the sector AOD area turns out to be 2.77. And here's our final step. Let's go ahead and calculate the area of this blue shaded region. And we already figured out our sector AOD area as 2.77 and the area of this triangle OED as 1. So let's go ahead and fill in the blanks in this equation. So this is going to be equal to 2.77 and then minus 1. And if we subtract this thing on the right hand side, that is going to give us 1.77. So thus the area of this blue shaded region turns out to be approximately equal to 1.77 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.